Hey there. Let's introduce reports in SourceScape, starting with something very simple, all uses of Lodash in our repos. Lodash is a somewhat controversial collections library in JavaScript, so presumably we want to deprecate it or something like that. Reports, to use the SQL analogy, add a group by to your queries. You can group by any of the fields in your SourceScape query, and you can also choose to group by repo or repo file. Without any base grouping or field selected, you're just doing a count. So here we have over 1,300 uses of Lodash across all of our repos. We can select the actual field, which is our Lodash utility function name. We can group by this field, and what we end up with is a count of the usage of each Lodash utility across all of our repos. For example, we can see here that we use default 93 times. We can also add repo to the grouping if we want to break down this data by repo. And we can do this as well for repo file. So that's a quick introduction to reports. Let's take a look at a few more use cases. Here's a quick and dirty way to get all environment variables used by your application. You could search for this as a string, but you would fail to capture cases where you first assign process.env to a different variable, or if you're using object destructuring. With SourceScape, you get a guaranteed way of capturing all uses of the environment variable. By creating this report, now you have guaranteed accurate documentation for all environment variables used in your application. You don't need to track this manually via spreadsheets anymore. Next up, React. We want to find all the different inline styles we're setting for our React components. So let's start with an anonymous JSX element. This has an attribute style, and its value is a dictionary. In this dictionary, we want to set an anonymous key so that we can pluck out its value later when grouping. Now let's run a report grouping by the name of the JSX element as well as the key in the dictionary. This will show us all React elements using inline styles as well as the inline style keys that they're using. If you're looking to move away from inline styles for performance or general quality reasons, this would be a great way of keeping track of this progress. For our next query, let's take a look at Mongoose. Mongoose is a Mongo ORM for Node.js. It builds up schema objects that take in a dictionary of document fields as well as their configurations. In our report, we want to pluck out document field names as well as the field type. These schemas are then passed into a model function, which defines it as a model with a collection name, which we also want to pluck out. Once we've defined our query, we can run a report grouping by collection name, and field type. Now we have a table of all our Mongo collections with fields and field types updated from code. Now let's take a look at Express. Express is the de facto HTTP server for Node. We want to find out how each of our Express routes is querying Mongo. We start by getting the router, which defines routes with a string for the HTTP endpoint as well as a callback function. In this callback function, we want to look at Mongo collection find calls. The particular style we're looking at here stores the Mongo database object in the request. Different code bases, of course, have different styles, but the more consistent your code base is, the more you'll get from SourceScape. In the find calls, we also want to pluck out the actual query we're using, specifically the keys that we're querying by. Now we can run a report that groups by our Express method, Express route name, Mongo collection, and Mongo query key. So what we've built up is a table of all our Express methods that query Mongo, as well as the keys they use in those queries. This is tremendously useful for getting a bird's eye view of how you're hitting your databases. You can easily imagine joining this data with server metrics to use for something like capacity planning. Now let's get back to React. For each of our React components, we want to get a list of all state keys that are being set from a fetch call. So basically all the state keys that hold remote data. We'll start by constraining our class using a render method. This helps us catch all React components, not just those that directly inherit from React component. Let's also add a constraint that will capture any method. In this method, we add a fetch call. Fetch calls return a promise but are usually handled with two then callbacks, the first being generally used for JSON parsing. The second callback is where we'll take the data and use it to set state. In this set state call, let's also capture all the keys that it's setting. For our report, we want to group by the React component name, the method that's doing the fetching, as well as the key that's being set. So now we have a listing of all the state keys for React components that hold remote data. This will be useful for a refactor where you're trying to figure out how to consolidate your state in a container component. SourceScape makes these rather sophisticated analyses of code almost mundane. Instead of very involved static analysis programs, these are just queries that you can write up in seconds. So I hope this has been useful as an introduction to SourceScape. Check out the demo to mess around with the query language. If you're interested in indexing your own codebase, please sign up using the link in the sidebar.